In this video about functional groups, we're going to talk about ketones. And ketones are the carbonyl, but instead it's in between two carbon chains. So you might have a chain of several carbons on one side and a chain of several carbons on the other side, and in the middle, or embedded into the chain, you have a C-O double bond. All right, so here are the rules for naming the ketone. You have this carbonyl that's wedged into a carbon chain, and you can think of it not as two carbon chains, but just one carbon chain with your carbonyl in the middle, okay? So how you're going to name it is we're going to use the ONE ending, and you're just going to list how many carbons and change the ending at the end. So for instance, if we had a pentane, instead of it being pentane, you're going to be pentanone. All right, and then you're going to position with whatever carbon number. If this was carbon 3, we'd indicate that in the middle. You can have multiple ketones, again, using di, tri, and the carbon number positioned where it is. If you add an OH group to your ketone, you're just adding the branch name hydroxy, and then you also give the carbon number. Again, the positioning would be based on the longest continuous chain, and you're going to try and get everything to the lowest branch possible. All right, so let's look at the examples. In the upper left, we have the 1, 2, 3, 4, 5. So this is a pent. It's all single bonds, so it's pentane. We're going to change the ending to pentanone, and we're going to tell people that the carbonyl group is on the second carbon, so 2-pentanone. Moving on to the right, we're going to number this with 1, 2, no, excuse me, that's backwards. We're going to number this 1, 2, 3, 4, 5. So this is a 5-carbon chain, so it's pent. And I'm not going to have enough room. Let me rewrite that over a little further. So pentanone, pentanone. But we need to indicate where the triple bond is. It's actually not a pentane. It's going to be a pentyne. My carbonyl group is on position 2. And my triple bond is on position 3. So let me rewrite that. So we've got 3 pentyne, and then we have 2 one for the ketone, that carbonyl group. Looking at the lower left, we see that we have a cyclo. So 1, 2, 3, 4, 5, 6. This is cyclohexanone. It's assumed to be on position 1. It's a circle. It's a ring. On the lower right, my carbonyl group is in the middle, so it doesn't matter if I number it left to right or right to left. So 1, 2, 3, 4, 5, 6, 7. This is heptanone. And I have some methyl branches. So I've got a 2 and a 6 dimethyl, and then I have a 4 heptanone. So ran out of room. That's a little bit hard to read. I'm gonna switch it up a little bit for us. 2, 6 dimethyl, 4 heptanone, if you're reading that along with me. Again, so there's some common naming. What they do is they break this carbonyl and call it 2 separate chains. So you have one chain and the other chain, and then you follow it with the word ketone. So in this case, and you alphabetize. So we have 1, 2 carbons. So this is ethyl. And then we have a 1 carbon over here, so that's methyl. And it's followed by the word ketone to indicate the CO double bond. Now, this is also a 4-carbon chain, so this would be 2-butanone if you followed the normal naming scheme. Again, so we're looking at the longest continuous chain locating the position of the carbonyl, and then adding the new ending.